Now that we know how to find the domain of a rational function, we're going to look at what it really means for a rational function to be undefined at certain points. For example, let's take f of x is equal to x squared plus 6x plus 8 over x squared minus 16. Okay? Now, if I were to find the domain for this, just like we did in the last video, I would say that x squared minus 16 cannot equal 0. Factor the top or the bottom, and you get x plus 4, x minus 4 cannot be 0, and then tells me x cannot be positive or negative 4. Now that we know what values we can't use for x, let's take a look at the graph and see what that actually means. So if I type my equation in, I've got x squared, can't remember what my equation was, plus 6x plus 8, plus 6x plus 8 over x squared minus 16. And I'm going to do a zoom decimal. That'd be zoom, then the number 4. And I can see, well, I can kind of look at my graph here and notice at negative 4, there's actually a hole in the graph. Now, if I had this in a standard window, I wouldn't be able to see that hole. And then when I come over here to positive 4, well, with this window, you really can't see much. So let me now go zoom 6, zoom standard. You get the graph there. And then on zoom standard at 4, it looks like my graph starts to go down forever. Then all of a sudden it jumps up to the top. So that's what we call a vertical asymptote. So in this particular example, we have both a hole and a vertical asymptote. So the goal is to figure out when we have a hole or when we have a vertical asymptote. Now we know it has to occur where my function's undefined. So I can narrow it down between two places in this example, positive 4 and negative 4. But how can I figure it out without looking at the graph itself? So what I'm going to do is take my function and factor both the top and the bottom. So the top will factor as x plus 4, x minus or plus 2. The bottom was already factored, x plus 4 and x minus 4. So you can see that in this factored form that x plus 4 is going to cancel on the top and bottom, giving me a simplified version of x plus 2 over x minus 4. Now, this simplified version has a similar graph to my original one. Let's take a look at it. So let me turn this graph off, and now I'm going to graph x plus 2, oops, we'll make it a fraction, x plus 2 over x minus 4. Now this is the simplified result of my original function. So if I graph it, in this window, it appears to be the exact same graph as the one before. As you can look here, I still have that vertical asymptote at 4. Now if I go back to zoom decimal, zoom 4, I notice here at negative 4, I no longer have that hole. Okay? Remember before, let me go back. Let me take this graph off and now graph the original function. Oops, forgot to turn it on. Graph. Now there's that hole at -4. Okay, so the simplified version is basically the exact same graph except for the hole. So going back to my math now, if you notice, this part that canceled out would have given me the undefined part of -4. That's why in this simplified result I don't have a hole there, because I don't have that part that makes it undefined. So how can we tell if there's going to be a hole or a vertical asymptote? Well, if you factor the numerator and denominator, holes cancel out. Okay, vertical asymptotes don't cancel. So we can tell from this example above that -4 here canceled out, or the -4, 0 there canceled out, so that is going to be a hole. So -4, -4 is a hole, and this value here that made it undefined, the +4, remained in my equation, so x equal +4 is a vertical asymptote. Okay, so in summary, to find these, first factor top and bottom. If anything cancels out, then that value that would have made it undefined is a hole. Then the value that's left that makes it undefined is the vertical asymptote. So how do we figure out where the hole is located? We know it's at x equal -4, but what is the y value of the hole? So in that case, we take our simplified result, x plus 2 over x minus 4, and we now substitute the x value for my hole. So my hole is located at -4. So I'm going to take -4 plus 2 over -4 minus 4. That's going to give me -2 over -8, which means I have a hole at the point -4, comma 1/8, or I'm sorry, 1/4. -4, 1/4 is my hole.